Hello world, good morning, good afternoon, good evening. Welcome back to codingscientist.com. You are watching Hero to Superhero, programming artificial neural network from scratch, from built up, right? You need to be proud. We have reached a long way from, starting point to almost a closure. Anyways, let's take a look at it. I'm gonna move on to my IDE, Visual Studio IDE, and we are going to get into the training aspects, right? So what training? It's a training of your neural network with the data which we imported from my GitHub repository. So guys, basically, it's a complete set of code which I combined bits and pieces of all the lessons you learned in the previous videos. So basically, as mentioned earlier, the network is basically updated using stochastic gradient descent. This involves first looping for a fixed number. Now, before I start explaining, you need to understand, what we are trying to do by importing some of these libraries, which I explained in the first lesson, and then we are initializing a network of just one particular layer, one input, one hidden layer, and one output, right? And then we are calculating the neuron activation for each input. So that's this particular section of code. And then we are transferring the neuron activation, and then once the transfer is done, we are basically forward propagating the input to the network output, right? So this is a critical piece which plays a major role in your artificial neural network. And then we are calculating the derivative of the neuron output, which is again a very important piece. And then we are back propagating again the error and store the neurons. That means from the output layer, we are getting the errors back into the hidden layer and the input layer. So we are trying to adjust the weights and then send the data back to retrain the system, retrain the artificial neural network, right? So that is this particular section of code. And then we are updating the network weights with the error which you saw in the previous lesson. So that's the overall stuff. And now in this lesson, we are going to look at how we are going to train for a fixed number of epochs, right? So what is epoch? So let me just try to explain you what exactly it is. So this involves first the looping for a fixed number of epochs, and within each epoch updating the network for each row in the training dataset, right? Because the updates are made for each training pattern. This type of learning is called the online learning. If the errors were accumulated across an epoch before updating the weights, this is called the batch learning or batch gradient descent. You need to understand this. I hope you guys know about this, right? So this particular function that implements the training of an already initialized neural network, which you saw in the lesson number 1, lesson number 2, with a given training dataset, which is our VEED dataset, and the learning rate and the fixed number of epochs and an expected number of output values, right? So epochs it's simply the number of iterations of training it has to go through within the neural network. It's as simple as that, right? So the expected number of output values is used to transform a class values in the training data into a one hot encoding. It's hot encoding within the code, right? This is a binary vector with one column for each class value to match the output of the network, and this requires a calculated the error for output layer. That's what exactly this code means. You can also see that the sum squared error between the expected output and the network output is basically accumulated each epoch and printed out. So this is basically helpful to create a trace of how much the network is learning and improving by each epoch. You run the code again and again for 10-20 different times, the output is going to be the same, but it all depends upon the number of epoch training you want to include, right? So we now have all the pieces of to train the neural network. We can basically put together an example which includes everything we have seen so far in the previous lesson, including a network initialization and then train a network on a small data set. Now if I run this code, basically you must basically see a kind of a contrived data set which can be used to test our training our neural network, basically. Now let's if you look at the code carefully, we will use basically two neurons as a hidden layer. Now it is the binary classification problem, like two different classes, right? So there will be two neurons in a output layer. You send an input again into the hidden and two output, right? So the network basically will be trained for 20 epochs with a learning rate of 0.5, which is basically high because we are training for very few iteration. It's very less iteration because the data set is pretty much small any which ways, right? Now we need to, most important thing, if I run this code running this particular example, it should basically print the sum squared errors on each training epoch. So we should probably be able to see a trend of this error decreasing with each epoch as and when we run this multiple iterations of this particular code. That is the neural network, right? So once it is trained, the network is printed out showing the learned weights. Also still in the network are the output delta values. Now let's go ahead and quickly run this, guys. Let's see what happens. So basically we are printing the data sets and see what happens. Let's touch wood, cross our fingers. I hope there are no errors. Let's try to run, and there you go, boom. Wow, I don't see any errors. Fantastic. You can see, can you see it here? Let me just expand this window so that you can see how our neural network works. So the number of epochs is clearly printing out, and it says that basically we could probably update our training function to delete this data as and when we wanted. So if you look at it carefully, we need to use this particular data set to make the prediction. That is the ultimate goal of building an artificial neural network, right? So anyways, guys, we are able to successfully execute our entire neural network, the artificial neural network. We are able to train the data set. We are able to do the back propagation. We are able to fix the forward propagation, and then our network is working precisely as intended. Now what next? The next is we need to do some sort of prediction, right? We throw a data and see what it says, that what was the past, what is the future, what is the current, some kind of prediction. That's the key. That's the product we build using for artificial intelligence, or using machine learning methods or deep learning methods, right? Anyways, I'm going to come back to you in the next lesson. You are going to enjoy the prediction aspects. Goodbye.